press the bell icon on the YouTube app and never miss another update.
Hello students, today we discuss one more type of problems in approximation. So formula 1 I say that in the last two classes f of x plus delta x is equal to f of x plus f dash of x into delta x. Today one more formula, formula 2 if you want. Formula 2 means delta y by delta x approximately equal to dy by dx. Delta y by what? Delta x. Delta y by delta x approximately equal to what? dy by dx. Delta y means what? Increment in y. Delta x means what? Increment in x. That implies delta y is approximately equal to dy by dx into what? Delta x. Delta y is approximately equal to what? dy by dx into what? Delta x. This is formula 2. So today we discuss the problems regarding this formula. Delta y means increment in y. Delta y means what? Increment in y is always equal to, approximately equal to dy by dx into what? Delta x. Okay, we take the problems. First problem, find the approximate change in the volume V of a cube of side x meters caused by increasing the side by 2%, caused by increasing the side by 2%. Say, observe here, find the approximate change in volume. The approximate change in volume, that small increment in volume, that I represented as delta V. Correct na? Approximate change in volume. So that I represented as delta V of what? Of a cube. Volume of a cube, you know in right measure. Volume of a cube V is equal to what? X cube. X is an variable edge of the cube. Correct now? So what has given of side? X meter. Okay, caused by increasing the side by 2%. So delta x is what? 2% of x. 2% of x. Increasing the side x meter caused by increasing the side. Side is what? X. 2% of x means delta x is equal to 2 by 100 of x. 2 by 100 of x, that is 0.02 into x. 0.02 into x means percentage he has given. Correct na? 0.02. Okay. So take the solution. We know that, first we write formula. We know that the volume of a cube V is equal to what? X cube. Where x represent what? variable h. Next line. Given increasing means we take positive values. Delta x is equal to 2% of x. Suppose if as given decreasing means we have to write the negative sign. So that implies delta x is equal to 2% means 2 divided by 100 into x. Delta x is equal to 0.02, correct now? 0.02 of x. This is what given. What we find? To find delta v. Delta v, correct? So I write here. Since v is equal to x cube, dv by dx is what? 3x square, correct? dv by dx is what? 3x square. So also we know that delta v, I use the formula 2, delta v is equal to delta v, small change in or as approximate change in the volume. If you want delta v means what? Approximate change in the volume. Delta v is equal to what? dv by dx into what? Delta x. Delta y is equal to what? dy by dx into delta x. That implies delta v is equal to, substitute all the values, dv by dx 3x square, correct, into 0.02 into x. So 3 into 0.02 is how much? 0.06 x into x cube. Unit also we have to write here, very important, very important. Unit also we have to write. What he has given? X meter. Volume, the unit of volume is meter cubic unit. So meter cube. 0.06 x square into x cube, meter cube. Observe the problem. He has given increasing the side by 2% means delta x. Side is side what we represent? X. Correct now? Variable edge x we have to represent the side. Delta x is equal to 2% of x means 2 divided by 100, 0.02 of x. So we know that since v is equal to not x square, x cube. V is equal to x cube. dv by dx is what? 3x square. So also we know that this is the formula. So what I explained beginning. So we use another formula, approximate change in volume or approximate change in y. Delta y means approximate change in y. If you want approximate change in y, delta y is equal to dy by dx into what? Delta x. Delta x approximate change in x. So I use this formula. So approximate change in volume, delta y is approximately equal to, if you want, are equal, no problem, dv by dx into delta x. Substitute here, so we got the answer. So 0.06 x cube, and here very important, we have to write the unit. If you don't write the unit, so 1 mark will cut. Clear? So see the problem. So this is another type of problems in approximations. Second type. Okay now, one more problem. Next problem, second one. If the radius of a sphere is measured measured as 9 centimeter with an error with an error of 0.03 centimeter. Then find the approximate error in calculating its volume. See the problem first. If the radius of a sphere is measured as 9 centimeter, what he has given? R is equal to, so I write one side here, R is equal to what? 9 centimeter he has given. R is equal to 9 centimeter with an error. Delta R also given. Delta R is what? 0.03 centimeter. This is given. What he asked? He asked find the approximate error in calculating its volume. So we have to find out approximate error calculating its value means delta V. So delta V is equal to what? dV by dr into delta R, because with respect to radius. Here with respect to what? Radius. In the previous problem with respect to edge. Edge is what? X. Here radius is what? R. Correct na? So we have to find out delta V. Delta V is equal to, I link to the formula 2. Delta V is equal to dV by dr into delta R. Before that we want the volume of a sphere. So we discussed already in the right measure. Volume of a sphere, V is equal to what? 4 by 3 pi r cube. Write the formula first. Solution. The volume of a sphere V is equal to 4 by 3 pi r cube, where, right here, where R represent what? Radius of the sphere. R represent what? Radius of the sphere. Okay. What he has given? Delta R is equal to 0.03 centimeter. To find delta V at R is equal to 9 centimeter. Correct now? R is equal to what? 9 centimeter. We know. Okay. So since delta V is equal to dV by dr into delta R, okay, that implies delta V is equal to dV by dr. I differentiate this one, directly write 4 by 3 pi, derivative of r cube with respect to r, 3r square into delta R. So 3 get cancel. Right here, delta V is equal to 4 pi r square into delta R. 4 pi r square into what? Delta R. So delta V is equal to 4 pi. R is what? 9, not 7. 9 square. 9 square into delta R. Delta R is what? 0.03. Correct? You also calculate. 4 into 81 into 0.03 into pi. 9.72 pi. Delta V is equal to what? 9.72 pi. Is it over? No. We have to write unit also. So he has given in centimeter. The unit is centimeter cube. Then it is over. Approximate error in calculating its value. Approximate change in volume. Approximate change in volume. Delta V is equal to what? 9.72 pi centimeter cube. This is very important problem for 3 mark questions. See the problem first. Clearly you have to understand the concept. If you know the concept, simple formula here, delta y, approximate change in y is equal to dv by dx into delta x. I use the formula. And even though the formulas of sphere, cube, rectangle, circle, these are all very important. If you know these things, you can easily to solve the problem. Clearly observe the problem. Next problem. Next one, third problem. Find the approximate. Find the approximate change. Approximate change in the volume. In the volume V of a cube. Of side x meters, side x meters, caused by increasing the side by 1%. Same problem what we discussed in the first problem. Caused by increasing the side by what? 1%. Same problem. So you also solve solution. Volume of a cube. P is equal to what? X cube. Correct now? Volume of a cube V is equal to x cube. Given what? Delta x is equal to 1% of x. Delta x is equal to 1 divided by 100 into x. Delta x is equal to 0.01 x. Centimeter. Okay, then since delta V he wants dv by dx into delta x, that implies delta V is equal to 3x square into delta x. Correct? 3x square into delta x. That implies delta V is equal to 3x square 0.01 into x. So increasing means we take the positive values. Delta V is equal to 0.03 x cube. Here what is given? The unit meter cube. X cube meter cube. Approximate change in volume. Delta V is equal to what? 0.03 x cube meter cube. Understand? So what we discussed in the first problem, same problem. Okay, clearly observe. Next problem. Fourth problem. Find the approximate change in the volume of a cube of side x meters caused by increasing the side by 3%. The side by what? 3%. Same problem. Okay, so solution. Volume of a cube. V is equal to what? X cube. Volume of a cube, V is equal to X cube. Given delta X is equal to 3% of X. Correct? 3% of X. Delta X, it is increasing means we have to take the positive sign. Decreasing means we have to take the negative sign. Delta X is equal to 3 by 100 of X. Delta X is equal to 0.03 into X. This is over. Since, so we have to find, right here only, to find what? Delta V. Since delta V is equal to what? dV by dx into delta X. That implies delta V is equal to dV by dx, simple derivative 3x square into 0.03x. 0.03x. That implies delta V is equal to 3 into 0.03 is what? 0.09 x square into x cube meter cube. Here also he has given meter. X cube meter cube. See the problem. This is very important problem. See this problem. So if you perfect about the concept, you can solve any type of problems. Next problem. See this problem first. Next one, fifth problem. Find the approximate change in the surface area of a cube, surface area of a cube of side x meters caused by, yes, one more point you observe here, caused by decreasing the side by 1%. Decreasing the side by 1%. See the problem. Find the approximate change in what? Surface area of a cube. We want what? Surface area of a cube. of side x meter. Here also the edge is x meter caused by decreasing, means we have to take the negative value, decreasing the side by 1%, decreasing the side by what? 1%. Solution. Surface area of a cube, you know the formula, S is equal to what? 6x square. Correct now? S is equal to what? 6x square. Okay, given delta x is equal to minus 1% of x. Why we write the minus? Because he has given decreasing, that's why I write minus. So delta x is equal to minus 1 divided by 100 into x. Delta x is equal to minus 0.01x. The unit is meter. The unit is meter. If you want to write, no problem. Since what we want, approximate change in surface, that only right. Delta S is equal to ds by dx, right here. Since delta S is equal to what? ds by dx into delta x. Delta S is equal to what? ds by dx into delta x. That implies delta S is equal to ds by dx. Differentiate S with respect to x. 12x into minus 0.01x. So delta S is equal to, if you multiply these two, 0.01 into 12 means 0.12 minus, we have to write here minus x into x square, delta S. That implies delta S is equal to minus 0.12 x square unit meter square. S square unit is what? Meter square. See the problem. This is also very important. Negative sign. So why we write negative sign? He has given decreasing the side by 1%. This edge of a cube is decreasing the side by 1%. That's why we write the negative sign. If it is given increasing, so we write positive sign. See the problem first. So one more problem. Next problem, sixth problem. If the radius of a sphere, is measured, as 7 centimeter with an error of 0.02 meter, then what yes we will say, then find the approximate error Find the approximate error in calculating its volume. Calculating its volume. Last problem. I think second problem we discussed this type of problems. So radius of a sphere is measured as 7 centimeter with an error of 0.02 meter. 0.02 not meter, I think it is. So here this one is not centimeter, this one is also meter. 7 meter. If the radius of a sphere is measured as 7 meter with an error of 0.02 meter, then find the approximate error in calculating its value. So solution. You also solve volume of a sphere. Volume of a sphere. V is equal to what? 4 by 3 pi r cube, where r represent what? Radius of sphere. R represent what? Radius of sphere. Okay. So I differentiate here also. Okay. dV by dr. 4 by 3 pi into 3r square. Correct now? 3 get cancelled. dV by dr 4 pi r square. 4 pi r square. So give one. What? Delta r is equal to 0.02 meter. This is given. Delta r is equal to what? 0.02 meter. Okay. To find delta v at r is equal to 7 meter. To find delta v at r is equal to what? 7 meter. Okay. Alright, here r is equal to what? 7 meter. Since delta v is equal to dv by dr into delta r, that implies delta v is equal to dv by dr 4 pi r square into delta r. So delta v is equal to 4 pi r square. R is what? R is 7 square into delta r. Delta r is what? 0.02. So 4 into 49 into 0.02 pi. Calculate. So delta V is equal to 3.92 meter cube. Delta V is equal to 3.92 pi. 3.92 pi meter cube. Same type problem. See the problem. Volume of a sphere. So dV by dr. So what he has given? Delta r is equal to 0.02 meter. To find dV at r is equal to what? 7 meter. So since dV is equal to means dy, approximate change in y, dy by dx into delta x, that implies dV is equal to dV by dr into delta r. Substitute 3.92 pi. If you don't write the unit, it will cut 1 marks. That's why. So here he has given the radius in meter. That's why I write meter cube. Understand? See the problem. Next problem. Next one. Seventh problem. if the radius of a sphere is measured as 9 meter with an error point 0.03 meter, with an error 0.03 meter, then find the approximate error in calculating its very interesting surface area, yes, surface area of a sphere. S is equal to what? Surface area of a sphere, S is equal to 4 pi r square, correct na? So what do you have to find out here? We have to find out delta S. He has given at r is equal to 9 meter and delta r is what? 0.03 meter. So write the solution. Surface area of a sphere. Surface area of a sphere, S is equal to what? 4 pi r square. S is equal to 4 pi r square. Okay. Surface area of a sphere, S is equal to 4 pi r square. Given delta r is equal to 0.03 meter. To find what? Delta S at r is equal to 9 meter. To find delta S at r is equal to what? 9 meter. So we differentiate this one. ds by dr 4 pi into 2r. The root of r square is 2r. So that is equal to what? 8 pi r. Delta S is equal to what? 8 pi r, correct? Delta S is equal to what? 8 pi r. Okay. Since delta S is equal to ds by dr into delta r. Delta S is equal to ds by dr into delta r. That implies delta S is equal to ds by dr 8 pi r into delta r. Delta r is what? 0.03. Okay. At r is equal to 9 meter. At r is equal to 9 meter, delta S is equal to 8 pi into 9 into 0.03. Calculate. All the values you have to calculate. meter square. 2 point delta S is equal to what? 2.16 pi meter square. 2.165 meter square. Understand? See the problem first. This is also very important problem for 3 mark. See this problem. This is very, very important problem. So in the examination it may ask in 3 mark question. Delta S is equal to 2.16. 8 into 9 into 0.03. So pi I write as it is. If you want, in all the problems, if you want, you substitute pi value also. Okay. So 2.16 pi meter square. Next problem. One more problem, eighth one. If the radius of a sphere, if the radius of a sphere is measured as 12 meter with an error of 0.04 meter, then find the approximate error in calculating its surface area. Last problem. Just now we discussed. Same problem. Its surface area. Okay. You also solve solution. The surface area of sphere S is equal to what? 4 pi r square. Correct now? The surface area of a sphere S is equal to what? 4 pi r square. Okay. Okay, ds by dr. That also I differentiate here only. So that is nothing but 8 pi r. Correct? Derivative of r square is what? 2r. Derivative of r square is 2r. So 2r into 4 pi, 8 pi r. So given delta r is equal to what? 0.04 meter. This is given. To find delta s at r is equal to 12 meter. R is equal to 12 meter. To find delta s at r is equal to what? 12 meter. Okay, since what? Delta s is equal to ds by dr into delta r. ds by dr into delta r. That implies delta s is equal to ds by dr. ds by dr is what? 8 pi r into delta r. Delta r is, okay, delta r. We substitute here. That implies delta s is equal to 8 pi r value 12. Delta r value 0.04. Calculate. .84 pi meter has given meter square. 3.84 pi meter square. 3.845 meter square. So see the problem first. So if you know very properly the concept, so any problem, any type of problem you can solve. This is very important concept. So in the annual examination, so 3-mark question, these are all very important. Today what we discuss, all the problems for 3-mark questions. That's why this is very important problem. See this once again problem, and even though, so remember formulas are very important. Only two formulas in approximation. First one is f of x plus delta x is approximately equal to f of x plus f dash of x into delta x, and next approximate change in y, delta y is equal to what? Dy by dx into delta x. And even though all the formulas, volume of a sphere, volume of a cone, volume of a cube, surface area of a cube, surface area of a sphere, area of a circle, all these formulas, even unit. If you don't write the unit, so they cut the 1 mark. That's very important. So this completes the approximation in application of derivatives. Okay na? This completes the approximation topic. So only we left two topics: increasing, decreasing function, maxima and minima. So in the next class we discuss the increasing and decreasing function. Thank you.